Hello, my wonderful coding friends. Welcome back to our channel. Today, we are going to unlock a very important and powerful concept in Java programming, generics. Have you ever faced issues with typecasting or runtime errors in your Java collections? Well, generics is here to solve those problems, making your code safer, cleaner, and much more reusable. In this 5-minute tutorial, we will understand what generics are, why they are so crucial for modern Java development, and how to use them effectively in your programs. By the end of this video, you will be confident in using generic classes and methods, and you will understand how they bring robust type safety to your applications. Let's dive in. Before we jump into generics, let us first understand the problem they address. Imagine you are using a traditional array list without specifying the type of elements it will hold. This is known as using a raw type. You can add any type of object to such an array list, a string, an integer, a boolean, anything. The compiler will not complain at all. However, when you try to retrieve an element from this list and cast it to a specific type, say a string, what happens if the element at that position is actually an integer? Boom! You get a class cast exception at runtime, which is a very common and frustrating error. This lack of compile time type checking can lead to unexpected crashes in your applications, making debugging difficult and code unreliable. This is exactly where generics comes to our rescue. Now, let us introduce the hero of our story, generics. Generics allow you to write classes, interfaces, and methods that operate on objects of various types, while still providing compile time type safety. How do they do this? By letting you specify a type parameter, like T or E, when you declare your collection or class. For example, instead of just ArrayList, you can declare ArrayList string. This tells the compiler, hey, this list will only hold string objects. If you then try to add an integer to ArrayList string, the compiler will immediately catch the error, preventing a class cast exception at runtime. This compile time checking is a huge advantage, as it helps you find and fix type-related bugs much earlier in the development process, saving you a lot of time and effort. Generics are not just for collections. You can also create your own generic classes and methods. Let us create a simple generic box class that can hold any type of item. We define it as public class box T, where T is a type parameter. This T acts as a placeholder for the actual type that will be specified when we create an instance of box. For example, box string creates a box that can only hold string objects, and box integer creates a box for integer objects. Notice how we use integer instead of the primitive int, because generics work with reference types, not primitive types. This flexibility allows you to write highly reusable code that works across different data types without sacrificing type safety. It is truly powerful, is it not? While generics are powerful, it is important to be aware of a few common pitfalls and best practices. Firstly, always avoid using raw types like just ArrayList. Always specify the type parameter, for example, ArrayList string, to leverage compile time type safety. Secondly, remember that generics in Java work with reference types only, not primitive types. So, if you want a box for integers, you must use the wrapper class integer, not int. Another important concept, though slightly advanced, is type erasure. Java generics are primarily a compile-time feature. At runtime, the type parameters are removed, and all generic types become object internally. This means you cannot create instances of type parameters directly, like new T. By keeping these points in mind, you can write robust and error-free generic code. And there you have it, my friends. In just 5 minutes, we have covered the fundamentals of Java generics. We learned how generics provide invaluable type safety, preventing those nasty class cast exception errors at runtime. We also saw how they enable code reusability by allowing you to write flexible classes and methods that work with various data types. Remember, using generics means writing cleaner, more maintainable, and robust Java applications. The key takeaways are: always use type parameters, prefer wrapper classes over primitives with generics, and understand the benefits of compile-time type checking. Now it is your turn to practice. Try creating your own generic classes and experiment with different data types. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java tutorials. Happy coding!